Hello folks, we are now starting our new chapter. It's chapter number 12 and it's called as Introduction to Three-Dimensional Geometry. An extension of this we are doing in the next year also, and this is the base of this. Now lots of things to understand in this. Of course we are not able to do that in this video. We directly take up the exercises. Maybe after the whole lot is over, we could take concept videos where we can focus on concept as to how this is coming. Now what we are going to do in this chapter is we are shifting from two-dimensional to three-dimensional. Two-dimensional was basically with our x-axis, y-axis, that is our two-dimensional space. Two dimension means two axes. So we had x-axis, y-axis, we only had a plane, and this plane either that it is the sheet of paper or it is the board for me. That was our two-dimensional two-dimensional plane, which we were dividing into four parts with the help of two axes, right? We were getting four quadrants. When we had our 2D plane, what we used to do is we used to have this two axes and it used to get divided into these four quadrants. This is what we were doing in the two-dimensional plane. Now we are going to have an extension of this. Instead of being in a plane in the flat surface, we are moving in this open space for example. And somewhere we are fixing a coordinate axis. Now we will have maybe it's the corner of the room, maybe where you will have an ideal way to look at it is look at the corner of the room, where you have at the bottom there is one line running, that is called as x-axis. That side there is one line running, that is called as y-axis. There is one line running on the top, that is called as z-axis. If you can imagine that way you can have. So what will happen is, suppose say in a room, if you fix all these three axes with whatever way you want, then the entire room is divided into 8 parts. That is more of your visualizing. You can imagine you have a stand, with the x-axis one big rod, y-axis one big rod. So we have placed that stand, x-axis, y-axis rods here, and then mutually perpendicular, they form a plus sign. We have fixed it. Then we take a z-axis rod and we plant it just perpendicular to it. If you see, the space will be then divided into 8 parts. Okay, because it is divided into 8 parts, each part is called as an octet. Something like what we did in the 2D space. Because there were 4 parts, each part was called as a quadrant. Okay, here because the space is divided into 8 parts, each part will be called as an octet. And we learned in the 2D space, there is a particular way of deciding the quadrant. Like if it is both the coordinates are plus plus, then it's in the first quadrant. Both are minus minus, then it is in the third quadrant, like that. So also in this particular part, they give us several coordinates like this. Obviously now when we were in 2D plane we had 2 coordinates. Now because we are in 3D plane we will have 3 coordinates. So for every 3 coordinates, depending on the sign, we can predict which octet it is lying. And to predict that, there is a ready reckoner. I have put it on the board, but otherwise you should know it also, that all the 3 pluses, it is first quadrant, first one negative, the other 2 positive, second quadrant, first both negative, third positive, third quadrant, middle one negative, the others positive, fourth quadrant, last one negative, others positive, fifth quadrant, first and last negative, the in between one positive, sixth quadrant, all negative, seventh quadrant, last 2 negative, eighth quadrant. So that way we will look at the vertex and we will predict which octet they lie. And as I said, concept wise, either if we have GeoGebra or something, we can work there, or then we have to actually be fixing a model, and with the help of that we will have to visualize. So that's about it. The exercise 12.1 is a small exercise, basically about the understanding, because we have to shift our understanding from two-dimensional to three-dimensional. Should start thinking about three-dimension. So, so basic questions based on that, whether you are able to think in those lines. The first question says that they are more or less objective questions. A point on the x-axis, if there is a point on the x-axis, then what is its y and z coordinate? Now you think of the 2D plane, and in 2D plane, suppose say you had a point on the x-axis. Okay, obviously it's of the type A0. What used to happen to the y coordinate? It used to become 0. Same way in a 3D plane also, if there is a point on the x axis, it will have only the x coordinate. It will not, because it's there on the axis, right? It's not at any distance anywhere. So it will not have the other two coordinates. The other two coordinates will be 0. Idea is just like what we did in 2D. So its y coordinate is 0 and its x coordinate is also, its y coordinate is 0 and the z coordinate is also 0. Now an extension of that, second question. A point is in the xz plane. It is in the plane, xz plane. Then what is its y coordinate? So you could have, as I said, 8 planes. Okay. Now generally if there is a point in the space somewhere, it is there in the space, then it will have all the 3 coordinates, x, y and z coordinate. If it's there on the axis, then it will have the coordinate only of that axis. And if it is there on a plane, then it will have the coordinate only of that plane. For example, as I said, I am treating my bottom line this way as x-axis, I am treating that line that way as y-axis, and this is my z-axis. This is how I am treating my octant. Okay. Suppose if I have point on this wall, then what happens? That point is on the wall, it is not in the space somewhere here. If it is somewhere here, it has got an x coordinate, it has got a y coordinate, it has got a z coordinate. But my point is not in the space, it is in the plane. Now this plane has got an x coordinate because this is the x axis. It will also have a z coordinate because it's a z axis. It will not have a y coordinate because y coordinate is moving that side, and it has got nothing to do with the y axis. It has got nothing to do. It has got only relations with the, when we drop perpendiculars, it will fall only on the x and z axis. It will not fall on the y axis. That's how we find out the if a point is there in the space, if you have to find out their coordinates, we drop perpendiculars. That's how we will get to know their x, y and z coordinate. Now because if this point is here, if you drop perpendiculars, then it will go only to the x axis and to the z axis. So we will get only x and z coordinates, will not get the y coordinate. So whenever it's in a plane, the y coordinate will be 0 because it was in xz plane. So keep this in mind. When it was axis, both will be 0. When it is a plane, one will be 0. So that's about it. Now this is quite easy if you know this, right? If you know this system, then we are able to, they give you vertices and we have to tell which octant it is lying. All 3 positive, first octant. Then middle one negative is the 4th octant. Then last 2 negative is the 8th octant. Then last one negative is in the 5th octant. First and last negative is the 6th octant. First one negative is in the 2nd octant. First 2 negative is in the 3rd octant. Last 2 negative is in the 8th octant. Why 8th is repeating twice, or something has not come also maybe. Yeah. They haven't given 7, all negative they have not given. Yeah, they could have done that. Everything could be given so that we would cover everything. So this is how we get your octets. Now there is a fill in the blank question. Same way, we'll keep our understanding ideas open and then we'll try to see how we get it. The x axis and y axis taken together will determine what? XY plane. You have the x axis, you have the y axis, you take them together, it will form the XY plane. Determines the XY plane. The coordinate of the points in the XY plane are of the type, if it's there, as I said, if it is a coordinate is there in the XY plane, it will have the x coordinate, it will have the y coordinate, but it will not have the z coordinate. So it is of the type a, b, 0 or x, y, 0 or h, k, 0. It's your wish. So that way, then coordinate planes divide the space into 8 octants. We just discussed it. So it will divide it into 8 octants. Now this is about exercise 12.1 where they are trying to just give you an insight about how the 3D plane is, and they basically want you to shift your understanding from 2D plane to 3D plane. Just an extension, that's all. It's just a matter of extending your imagination. So that's about it, and then with the next exercise we are coming in the next video. Thank you.